Our research group at Harvard, as well as many others, have been working in the area of soft robotics. This is a very new and quickly growing area within the robotics field. And people think about exciting applications such as, robots that help people move, or robots that people can interact with safely in different environments. And we've also realized that this is a topic that gets young people and young students very excited about fields in science, technology, education, and math, so STEM topics. And we really wanted to think about how would we make this more accessible to people and allow more young people to get involved in this exciting research area.
One of the ways in which we inspire the next generation of engineers and innovators is by showing them what's happening in research so they can get excited about their futures in STEM. When this is happening in a practitioner-delivered fashion, it really limits the number of students who can benefit from this outreach. And so our two goals for developing the curriculum were that it was able to be delivered remotely or virtually. This was necessary during the COVID-19 pandemic, but after the pandemic, it really enables us to expand the number of students that can benefit from the curriculum. And second is that we wanted to empower teachers. One of the major barriers to bringing robotics into classrooms where it doesn't already exist is teacher confidence. And so we focused on developing a workshop for teachers that would allow them to experience the curriculum and to see its design thinking framework that would enable them to personalize the curriculum for students in their specific region and area and local area. And so with these two thoughts in mind, we developed a robust virtual curriculum that can be delivered such that the Soft Robotics Toolkit doesn't have to only exist in the lab or even just in schools now. It can be used at home, and the students can build soft robots, and then afterwards they can get inspired by a potential new application of their soft robotic gripper, or thinking about the gripper in a new way and using human-centered design principles, they can design and actually prototype with the Soft Robotics Toolkit their own improved gripper. And this is exactly what engineers do every day. And so it really gives them the opportunity to, practice their engineering skills.
So a lot of robotics education kits today do a great job focusing on programming, but there hasn't been as much exploration in terms of creating kits that would help people with making and manufacturing and help them understand different types of materials. And so that's really kind of where we focused on. So, the kit that we've developed allows students to practice making, using different types of soft materials, and really kind of creating from scratch their own soft robot system. And then in addition, being able to add on some electronic components and also do a little bit of programming as well. So really it allows them to get the full picture of what it's like to create a soft robot. In addition to that, we've also really had a focus on making these accessible to as many people as possible. And so we really try and focus on keeping these kits simple and making them as low cost and affordable as possible through the materials and the design that we've used. And then we also want to try and think about kits and topics that can, inspire a diverse, group of people to kind of get involved and use these as well. So really trying to think about having as broad an audience as possible be excited about working on these different types of topics.
So through this project, we're evaluating teacher confidence, teacher self-efficacy in delivering the curriculum, as well as student engineering identity and confidence in STEM. It was so exciting to see the teachers, from the first day when we met them online to finishing up the workshop with their newfound confidence in delivering the curriculum and excitement to actually getting to visit the students in their classrooms was really great. And they've been presenting their work to us. And it's just been really, really exciting to see, the confidence and agency that they bring to these projects.
So one of the things that we learned going through this pilot is that, in addition to the kit itself, it's really important to have a curriculum that can go along with it in order to kind of guide students and teachers through kind of building it and highlighting the different aspects that we really want them to learn and get out of this as well.
Here's an early prototype of the Soft Robotic Toolkit, the Tendon Actuator Gripper Kit. We designed this to show students how bio-inspiration can be applied in robotics. So for instance, this Tendon Gripper Kit is fingers that are casted out of silicone using a mold that the students assemble from acrylic, and then we put string through the fingers, and then it's operated through a motor on the inside and a microcontroller. And so the pulley actuation pulls on the string, closing the fingers, and that's similar to how the human hand works, where the tendons are pulled from the fingers in the forearm and not actually, there's no muscles in the fingers. So that's kind of the bio-inspiration thought behind this kit, and we thought it'd be a really nice, multidisciplinary application to incorporate into classrooms that showcases kind of how soft robotics can be applied in real world applications. So grippers are, right now they're used in supply chain applications in factories, pick and place. They're also, more specifically, soft robotic grippers are being used in marine life to pick up delicate animals. And so we make all those connections in the curriculum that we've developed along, with building the hardware. And the goal with this part of the kit is to excite students and show them what soft robotics is, hopefully get them inspired to go further and start wanting to build their own soft robots. And we do that in the second part of the kit called the Exploration Kit, this being the introduction kit. But the Exploration Kit, we just give them raw materials, silicone, cardboard, paper, hot glue gun, and they end up going through the full design process of coming up with a problem that they see with this gripper, and then deciding what they're going to do to solve that problem, and then sketching ideas on paper, prototyping with cardboard, rough prototypes, and then building a final design using silicone and whatever other materials that they want to use. And the idea for that is to kind of get them used to what a design process would be in a research lab or even in industry, where it's iterative and there's a lot of failure. You make multiple things, multiple prototypes, and we just wanted to bring that kind of real world experience to the classroom.
So the support from the Tata Trusts and also from the South Asia Institute at Harvard have really enabled us to run a pilot at a scale that we just wouldn't have been able to do otherwise. And that's been really exciting for our team and a very new direction. And so I think that going forward, what we'd really like to do is try and think about how we build on this work. So how do we go from, a pilot of, 50 or 100 students to 500 or 1,000 students? And so our team is very motivated and excited about how we start thinking ahead for that next step at the moment.
In preparation for this project, before rolling out the curriculum and the Soft Robotics Toolkit in India, we ran a pilot here in the US. Through that process, the students here in the US became really interested in what the students in India would be working on, and they actually ended up becoming part of their class going forward. So the students from the US visited the Indian classrooms, and they shared ideas with one another about what they were building and some ideas that they might have. It was really great to see this cross-cultural collaboration, and now the students, at a very young age, can collaborate with other students around the world to help further develop their sense of engineering identity and confidence in pursuing STEM fields.